Assalamu alaikum warahmatullahi wabarakatuh. I am Al-Dailami with matric number 1622847. I want to present my FYP project, which is Arabic speech recognition using neural network. For the introduction, the Arabic language is rated the 6th place after French language, with around 2,700,000 speakers all over the world. And it's an important language because of the massive number of speakers. And sophisticated technology plays an essential role to ease the interaction between the machine and human being. One of the most or smartest application in this field is speech recognition. Unfortunately, however, Arabic language is still late in this area because there is no significant and reliable dataset as the English language, and also because of the difficulties of the language. This project, its its aim to achieve a good result in Arabic speech recognition by receiving Arabic speech and convert it to text using neural network and natural language processing. For problem statement, there is a huge obstacle while associating with atomic speech recognition, and this is because variance of background noise, crosstalk, talker dialects, and transcriber inconsistency of reference transcripts. These difficulties reflect the need of the Arabic speech recognition application to deal with Arab speakers. However, there is a huge demand in the atomic speech recognition in the near future. People who suffer from communication disability in general, they may have solutions on their problem with atomic speech recognition. My objective is to design a method to convert speakers' sound waves to text based on deep learning, and to develop an algorithm based on neural network and NLP to recognize Arabic speech and determine the best outcome of speakers. For the methodology, it can be seen that we start with data collection. And for my project, I find a data collection with an average in total 5 hours. It's around 2,000 file recording. We will take this data collection and we will apply it for data pre-processing, because we need to clean this data well, and then we will read all this wave audio file and generated spectrograms. Why we need to generate spectrograms? Because we will deal with this spectrograms later. And slicing the audio files, because the audio files, it's really large for the machine, and we need to slicing, and then exploratory the data analysis and visualization. We will segment. We'll do segmentation with the data. It's 80% for training and 20% for testing. And of course, either training or testing data, we will use feature extraction, which is null frequency substral coefficients. This will abstract the feature abstraction algorithm. It will improve the training data and testing data, because it's make the sound more pure, or machine can deal with the sound. And then we will then in training data we will build CNN model, and for testing, of course, we will predict the accuracy, and then we will come out with the result, and we will finish our program. And then literature review. For the literature review, the overall or the summary of literature review, and there are many algorithms to recognize the sound. The common algorithm is CNN, DNN, ANN, RNN, and HMM. And we have generally speak recognition process. It takes 3 main steps, which is acoustic processing, we need to clean the data, and feature extracting, and third, classification recognition. Training the machine with speech dataset is more better than word dictionary dataset in terms of accuracy. And finally, null frequency substral coefficient, which is MFCC, is the best and the most common for feature extraction from audio. And for the modeling, I use CNN. For this modeling, this is the audio WAV file, and of course CNN have a layer which called convolution layer, and second layer max pooling layer. In this, the first layer, it's conv layer, it takes or applying a function to filter the WAV file, the recording file, and then after that we have to filter this recording file within a function involved the conv layer. The next layer, which is max pooling layer, it's after conv layer. Basically, this layer, the second layer, it takes the best feature from the conv layer. So the conv layer, it's filter the audio with the best wave, and then the next layer it takes the best value from conv layer, and it can be repeat this layer, conv layer and max pooling layer, many times in order to get a pure result or high accuracy. And then after this too, we have to use flatten layer. Flatten layer, it's actually to convert from polyed feature map to a single column, and then the fully connected hidden layers, and at the end, which is dense layer, as output layer. For this, I used, of course, Python, because it's the main program that I will work with, and TensorFlow, it's actually a library in deep learning. Scikit-learn, it's a machine learning library. Keras, because this I needed to build the layer, and Librusa, I needed to deal with the audio file, and Illustrator for designing. And this my two references, the best two references. Thank you very much for watching my video, and assalamu alaikum wa rahmatullahi wa barakatuh.